Welcome to ClickMyProject.com. Let me discuss about the project, an energy balanced routing method based on forward aware factor for wireless sensor networks. Let me discuss about the abstract of the project. Here the paper implemented based on the enhancement system. Energy saving optimization becomes one of the major concerns in the wireless sensor network WSN routing protocol design due to the fact that most sensor nodes are equipped with the limited non-rechargeable battery power. Here focus on minimizing energy consumption and maximizing network lifetime for data relay in one-dimensional Q network. Wireless sensor and actor networks have been increasingly popular for environmental monitoring application in the last decade, while the deployment of sensor nodes enables a fine granularity of data collection. Resource-rich actor nodes provide further evaluation of the information and reaction. Quality of service and routing solutions for WSNs are challenging compared to traditional networks because of the limited node resources. WSANs also have different QoS requirements when wireless sensor networks, since actors and sensor nodes have distinct resource constraints. Efficient energy optimization protocol for WSN in order to improve the communication ability. To achieve efficient communication can be reached by ACO FAF EBRM protocol and colony optimization based FAF EBRM. In this protocol, the next hop is selected by the movement of ant, which is based on the link weight and transmitted receiving energy. At last, they analyze the performance based on the result which outperform the existing method such as FAF, EBRM, Leach and EEUC. Let me discuss about the flow diagram for our process. Initially, the network model has been designed. All sensor nodes are isomorphic and they have limited capabilities to compute, communicate and store data. Set of sensor node is defined as B and N is the total number of nodes. Here 1 is the identifier for a node. Energy of sensor node is limited and the initial energy is E0. Nodes die after exhausting energy entirely. However, the energy of the sink node can be ordered. Locations of nodes and the sink do not change after being fixed, and a node cannot obtain the absolute position depend on its own location device. Nodes can vary transmission power according to the distance to its receiver. Sink node can broadcast message to all sensor nodes in the sensing field. The distance between the signal source and the receiver can be computed based on the received signal strength. Regional central nodes are not selected at the beginning. On the contrary, they spring up during the topology evaluation. Important nodes have more connections whose degree and intensity are significantly higher than neighbor nodes. Next, forward transmission area. Forward transmission area of a node is FTA. In WSN, clustered hierarchical routing protocol, sometimes nodes of a cluster are closer to the sink than the cluster head is, but it should transmit data to the head node. If the backward transmission is frequent, it must result in a waste of energy. FAF EBRM design. In FAF EBRM, every time node I finishes transmission, check the point strength of the next hop node J. If it is less than the average value of all the sensor strengths in FTA, the local topology reconfiguration mechanism should be launched. Node I FTA. Before the topology reconfiguration mechanism is launched, remove the link between I and remove from FTA and get a new set FTA. that is SFTA. The reconnect in FTA and the functions of connect possibility is given. Node removed, it may be possibility is given us. The node removed in that may be possibility next hop. When the next transmission is finished and the revocation of the edge does not affect the possible reconstruction, the node's real-time strength is needed to calculate the sum of strengths. Performance analysis. Based on this work, the energy balance routing method FAF EBRM based on forward aware factor is tested. In FAF EBRM, next hop node is selected according to the awareness of link weight and forward energy density. A spontaneous reconstruction mechanism for local topology is designed additionally. Let me discuss about the running procedure for our process. Select the main.m file in the controller, select the file and run for executing this process. Here we have to enter the number of cluster head between 10 to 15. Here this is the variant diagram representation where dot points represents the cluster head, and here the number of nodes to be deployed from 50 to 100. Now the number of bits for data transmission from 0 to 1024, 56 bits. This is the variant diagram representation where cluster heads are deployed. Here the nodes are deployed, and here the sinks are located, and this is the distance between nodes and sink. This is the distance between each nodes. This is the forward transmission area. Here the sink are located here, and if this cluster head will pass the data, then it will transmitted directly to this sink. If cluster heads are placed here, then the data transmission will be performed via this direction. And forward transmission area will here the minimum area of FTA, forward transmission area. This is the EBF between varying the number of rounds. This graph plotted between ACO, FAF, EBRP and FAF EBRP algorithm. Here NLN and by varying the number of rounds between ACO and also our existing algorithm. And here the PRP versus number of rounds between ACO, FAF, EBRP, FAF, EBRP algorithm. Here the data transmission will be performed via the forward transmission area. Here we combine the artificial and colony algorithm. Thank you.